Hi guys, I have my Mendocino style electric motor here. I'm giving it to my mother and she dropped it and broke one of the wooden pieces off and the ball bearing off the end of it, so I actually have to go through and rebalance it, and I had to run another wire, secure a couple connections. As you can see, it's not running under this light, and that shows you first off how critical the balance of it has to be. It has to be spot on for this thing to run in just under an incandescent bulb. I kind of wanted to show you guys the reason as to why this works and how DC electric motors actually operate. And there's a couple of rules we go by, and the main one is the right hand rule. Say we have just a wire and positive is coming in on the left side and current is flowing in this direction and negatives on the top right. If I take and pass this current in this direction, I'll use my thumb, and I subject it to a magnetic field perpendicular, that will result in a force that is perpendicular to both of them. It would actually cause this wire to turn towards us if it were in the presence of a magnetic field north. Once it gets past center line, you'll notice on this side the current is actually flowing down now. If it were somehow magically able to stay attached in the same polarity through the wire, this side would actually be traveling down and our right hand rule would flip. So if nothing changed and this wire was still subjected to the same magnetic field, this wire would flip back around and it would do the same thing. This would just sit here and twist like this, which is not a useful application to make an electric motor. I'm too open-minded to say it's not a useful movement, but it can't be used for an electric motor, and that's really what we're after. So we could do a few things to get this to actually make a complete revolution. One would be to switch the polarity of the magnet to south as it came across its center point, but that's really not practical. The easiest way would be to change the flow of the current through the wire as it came across center line. That way, as it came across, we could switch the current. This would now be negative, this would be positive, and then the flow would end up in the other direction. And then it would continue its revolution, and if we could keep switching it, it would keep revolving. And that is exactly how DC motors work. I have here just some small DC motors out of a car. Here's a complete one. You have the shaft out of it. You have two terminals that come in, the positive and the negative. And what's cool about permanent magnet DC motors is if you switch the polarity, the motor will actually run the opposite direction, which is kind of neat. But here is why they work. Inside of it, you have an armature, and then on each side of the armature is a magnet. The armature actually looks like this. This is a 3-pole. It has, it's pretty hard to see, on the end of this, 3 bars where these coils of wire come and attach. None of them really attach to each other, and this is called the commutator bar. You've probably heard that before, along with the word brushes. And these brushes are attached to the outside pins to make your motor run, where the positive and negative go, and they actually direct current to the back side of this commutator bar. And as it is energized and rotates, it disconnects and connects to the next coil and causes it to rotate and disconnects and connect, and it just keeps going, and that's what causes it to actually spin. So on our solar motors, we're going to have to come up with the same thing. Otherwise it's just going to sit there and flip-flop and not do anything. So what we're going to do is design a armature with 2 coils and 4 solar cells, and these solar cells are going to be arranged that the ones on opposite sides, top and bottom, are connected to one coil, and the top and bottom of the other side are connected to the other coil. And we can actually put positive and negative on the top, so as the sunlight comes up, it's a certain current flow, and as it comes up to the next one, it switches it so that we can continue the revolution. And I hope that sort of makes it clear as to how we're getting this done. I will do diagrams and everything. There's not going to be a test, so I'll explain it better. I hope that gives you a little insight.